Hey everyone, thanks for joining us. This is Jim Armstrong with Snyk. Just want to let you know we have about 2 minutes until we start the actual presentation. We'll start right at the bottom of the hour. But I appreciate everybody who's joined so far, and we'll talk to you here in just a couple minutes. Hello, everybody. Thanks for joining us for today's webinar. We're going to be introducing a new Snyk feature today. We have Gareth Rushgrove, who is one of our product directors here at Snyk, and he'll be leading you through the presentation and a demonstration of the feature. My name is Jim Armstrong. I'm part of the product marketing team here at Snyk. So I'll be behind the scenes answering some questions. If you have any questions during the webinar, feel free to use the Q&A panel to ask your questions at any time. I'll answer them as we go. And if we have some questions that are generally applicable, I'll bring those up at the end, and Gareth and I will get those answered for you. So feel free to use the Q&A panel, and at that, I will hand it off to Gareth. Gareth, take it away.
Oh, thanks a lot, Jim. Okay, we'll get started talking about using Snyk to secure your Kubernetes configuration. So I'm Gareth Rushgrove. I'm, as Jim mentioned, one of the directors of product at Snyk. Specifically, I work on all sorts of things related to containers and Kubernetes and cloud-native systems. So in this webinar, I'm going to talk a little bit of context first. We'll talk about configuration security, what that means, why it's important, why it's interesting. And we'll look at that in the context of Kubernetes specifically. So why is this relevant to Kubernetes? What are some of the challenges that Kubernetes brings when we talk about the configuration? And what can we, and importantly then coming on to what we can do about it. We'll do some demos of a new Snyk feature that's in the space that we're just releasing now. And then we'll wrap up with a few talking points, and we'll do some Q&A. Okay, so let's get started. So, configuration. Ultimately, it means lots of different things to lots of different people. We're mainly talking about here in the context of, I guess, modern systems being managed by infrastructure as code. We've really seen that shift, I guess, over the last maybe even 10 years, certainly the last 5 years, of organizations moving where they can do to configuring systems using some sort of code, some sort of data structure, often as well. And this, I guess, has been formalized through a number of different tools. And prior to that, yes, people were using all sorts of different configuration approaches. Some people were starting to experiment with code, but it was really with, I guess, tools like CF Engine, with Puppet, later with Ansible, that we started to see this crystallize into what became known as infrastructure as code. Since then, we've seen CloudFormation from AWS and ARM templates in Azure, and in particular, Terraform is a good example here. A widespread of different sort of domain-specific tools for configuration of infrastructure and applications, really managing that configuration, as I said, in code, whether that's some specific DSL or in fact, in YAML files. In particular, we've seen, I guess, over the past several years, the rise of YAML as the sort of de facto language of configuration. For good or ill, it's definitely here to stay. And you see that really with the millions and millions of YAML files you see publicly on GitHub or GitLab or wherever it might be. Worth saying, not everyone thinks this is a great idea, but it's definitely where we stand today. I think it's easy to sort of look at, I guess, infrastructure as code as something which is both either, yes, that's what you've always done, or actually, no, this is just for the new things. Really depends on your context in which types of organizations you work in. I've worked in both sort of like relatively young startups where everything was done that way. I also used to work in the UK government where it was very much basically the thing that was pushing forward on the newer bits. But one thing to say is the sort of growth of this is definitely sizable. And if you look at even the publicly available bits of source code, the bits of configuration, bits of these infrastructure as code tools on GitHub, so we're really then looking at only public configuration. And again, most configuration is definitely going to be private. This is definitely the sort of tip of an iceberg. And we're only looking at GitHub there as well. So it's only one repository of such things. But you still see huge numbers here. And over 2 million Kubernetes configuration files, hundreds of thousands of Terraform files and ARM templates and compose files. The sort of spread of this configuration is like there is ultimately lots and lots of it around. Unfortunately, and configuration is a security risk. This isn't specific to the fact you've put it in code, the fact you've used one of these infrastructure as code tools. Ultimately, configuration has always been a security risk. And it's one that's becoming, I guess, more high profile, especially with the adoption of cloud services, where nearly everything you're doing is configuration. It's not actually, you're no longer doing the physical, like manual work of racking and stacking those servers. Everything's about config. A good example of this, or an unfortunate example of this, was the recent Capital One incident. And they said themselves that like the exploit here wasn't, it was a configuration vulnerability. I think that was the first time I'd seen those two words put together like that. And I think that's an interesting sort of case study. You see in the work of some of the other folks in the security community as well, and Rapid7 with their penetration testing work. And this quote from a recent report I found particularly interesting. Like, some kind of misconfiguration is encountered on a penetration test over 96% of the time. So basically, most of the time, penetration testing is revealing configuration issues. I think it's clear that everyone is aware of this problem, but who's actually doing work here is a different matter, I feel. And this quote from the US National Security Agency, like, really gets at it, that while the cloud service providers are starting to provide tools here, and the most prevalent cloud vulnerability is still related to misconfiguration. It's not just a tool that you can solve, I guess, at the end. Like a lot of security problems, it really benefits from a more holistic approach throughout the development lifecycle. So what's all that got to do with Kubernetes? Well, Kubernetes is really one of those tools, I guess, that came along in the middle of that sort of shift towards infrastructure as code. The sort of the ubiquitous Kubernetes YAML file, if you like. And I think for most people watching this, you're probably familiar or over familiar with files like this. You might be writing them by hand. You might be generating them. You might be using higher level tools like Helm as a package manager, or Kustomize, or the new KApp tooling. There's lots of tooling here, but it all comes down to ultimately building out these data structures that are sent to Kubernetes. And you really see this in that GitHub dataset I mentioned. There are over 2 million Kubernetes configuration files like public on GitHub at the moment. That's definitely increasing all the time. And again, remember, that's just the tip of an iceberg. How many of them out there total in public? I wouldn't want to hazard a guess, but obviously it's going to be, what, tens of millions? That's a scary thought when you consider that there can be configuration security problems resulting from those files. And ultimately, there's an assumption here that you really need to sort of question. Stealing the sort of check your assumptions phrase from Ian Coldwater and like from the presentation that they've done a few times called the path less traveled. Ultimately, Kubernetes is not secure by default. Like that, there are many good and maybe bad reasons for that. But ultimately, at the application level, like your Kubernetes cluster is maybe not set up to be like the most secure thing. It's possible that your administrators have made some changes there, and different distributions do better or worse here. But Kubernetes is optimized to make it easy to deploy things. That's what you're trying to do with the platform. Ultimately, that means not everything is as locked down, as secure as it might be. That's not a bad thing per se, but it is something you need to be aware of. Like, the thing there is, nor are the applications you're deploying on top of it. That might be in terms of how they're configured to run on Kubernetes, or it might be the applications themselves. So maybe you do have a hardened cluster. Everything is locked down, that all the configuration is correct, but the application that you're running in your secure cluster happens to have a SQL injection vulnerability. You're still in trouble, basically. I'd say definitely check out the Path Less Traveled talk that really digs into a number of areas around Kubernetes and sort of the insecure defaults. A few examples of that, just to get us started, though. And one area is, by default, your containers are likely to be able to use as much memory or CPU as they need. Obviously, that's easy. And again, like if they need more CPU, if they need more memory in a well-behaved world, well, why can't they use that? Assuming that you have clusters that are scaling out fine, that you don't have concerns around money, there might be other reasons why you want to impose limits. Well, this shouldn't be a problem, right? Unfortunately, if someone wants to launch a denial of service attack, the idea that one of your applications can use as much memory or CPU as it likes, potentially all the CPU and all the memory of an individual node before it flips to another one and does the same thing, that makes obviously a denial of service attack much easier. Yes, you'll want to protect against sophisticated denial of service attacks in other ways, and certainly outside your cluster, the network edge. But imposing limits is a simple way of starting to mitigate some of those risks. Another area is actually running containers by default as root. Again, frankly, this just makes things easier. Software often makes assumptions about being able to do everything. Constraining what it can do might make it not start. Well, so the default is, well, run with root. It also has the slightly misleading or hard to parse, at least, property name as run as non-root. This invariably causes consternation everywhere I've seen it. But really, remember, you need to configure Kubernetes to run your applications without the root user. Similarly, with applications boot with a writable file system, the reality is they probably don't need one. And having one ultimately opens up another vector for attack. If someone is able to execute command in the context of your application, if they can write to disk, well, maybe in the worst case, maybe they can start dropping a rootkit. Maybe that goes away, but the next container will have the same problem and they can put it back. Really, writable file systems are, again, something if you can avoid, it's a good practice. That's nothing specific to Kubernetes or indeed containers. That's always been a good idea. And actually, Kubernetes makes this much easier to implement than you would have the hoops you would have had to jump through with a standard operating system. But again, the default is you get a writable file system. And very few people in my experience remember to set the read-only root file system true. And a final example for now, but we could go on like this for a while, is Linux capabilities. By default, the containers are likely to have the full power of Linux. They can do anything. They can that the user basically has permission to do. Maybe interact with the low-level system calls, interact with the network itself. Your container might not need to do all those things. And again, from a least privilege point of view, why not hook into the power of the Linux kernel to protect your application and the other applications running on your cluster? Again, there's a level of complexity here. You need to understand what calls your application actually needs. But a good practice here is, again, to simply drop all the capabilities and only add the ones back that you need. Again, it requires a bit of work to work out what they are, but you should know how your application works under the hood. So, and a few examples there, but there are lots more. And not just in the basic standard Kubernetes sort of deployments and container specifications I mentioned there. You can also look further afield into services and the sort of ingress and egress space. Also into third-party applications, which are introducing Kubernetes extensions. So Istio would be a great example, allowing you to configure your service mesh, allowing you to configure a quite complex virtual network. And we know networks can have security issues, and we have the same issue there. So as a quick example, can people spot the issues in this code? Now, there might be some people who are sort of waving their hands and saying, yes, I can. But the real question there isn't, can the experts, can people who've been close to this conversation and topic do so? The reality is we shouldn't have to. And looking at even a small snippet of code here and saying, oh yeah, like these are the security problems, requires an awful lot of domain knowledge. It requires an understanding of Kubernetes configuration files. It requires an understanding of the defaults in the system. It requires an understanding of what those defaults actually mean and how you override them. That's a lot of context for the sort of, even the Kubernetes experts. But really, you want to be pushing this out to more teams, or you are already pushing this out to development teams who don't want to have to be like that Kubernetes expert. So in this case, well, that container is running as root. It hasn't dropped capabilities. It does have more access than it really requires. And it doesn't have any resource limits. It's not limiting the amount of CPU or memory limits we set. Again, they're just picking up on some of the examples I gave. There are other hidden issues here as well, even in this small snippet of code. So, and hopefully at this point you sort of, I guess, buy the context and the problem. It's not, I think, unheard of at the moment. There's a growing sort of bunch of people talking about configuration as a security like sort of problem, and also talking about what we can do. And at Snyk, we've been thinking about this for a little while as well. So we want to show you what we've been up to. I'll jump straight into a demo because I think it's nice to sort of see this, but we'll come back and step through the different bits of features as well. So jumping over to Snyk. So for those that you haven't seen Snyk before, this is what the dashboard looks like when you just create an account, connected your source control system, and you're ready to import some projects. So let's start with adding a project. Snyk supports lots of different types of projects, but I'm going to import a project from GitHub. So all I'm doing here is basically selecting a specific GitHub repository, in this case called Snykit, one of my demo applications, and it's in my namespace. So we'll give that one moment to import the project, and hopefully we'll see things working. There we go. So really quickly, we've imported the project, and I can refresh screen and see what we're going to we're going to look like. So here we've imported Gareth Snyk as we specified, and we've detected a few things. One of them was a gemfile.lock file. In this case, this was a Ruby project, just a small service, fairly trivial, and that actually has some vulnerabilities. That's what Snyk's been doing for several years. I won't dig into that here, but definitely check out our sort of capabilities around detecting open source vulnerabilities in lots of different types of programming language and frameworks and applications. What I do want to talk about here is the new capabilities, a few things that we picked up on that we hadn't been doing before, namely these two Kubernetes projects. So let's dig into it, have a look. So here we can see we detected a Kubernetes configuration file in that repository, basically for deploying that application. Well, we also detected a number of issues with it. So we can see here that the container actually is running as root. We can get a sense of like, well, where that's affecting. We can also get a sense of, well, why that's a problem. We'll be doing more to help you actually fix these issues in the coming weeks and months. So you can really dig into the specific issues that you're discovering by navigating either in the context of the configuration file that you've written, or just simply looking through the issues. With each of the issues, you might decide that, in your case, that's not a problem. So I'm actually, in the context of this application, the fact that the load balancer surface is fairly open, I'm happy with. I'm not seeing that as an issue. So let's ignore that. I'll decide that that's not something I'm going to fix. And we'll choose to ignore. Again, that gives me the sort of context of the system is recommending things, but I can always bring my own defaults too. So let's see us fix some of these issues though. As I say, we'll be doing work to automate some of the helpers we can do here soon, but let's do that by hand for now. So this is my Kubernetes configuration file. I'm actually using a templating tool. The tooling works fine whether you're using just flat files or some sort of templating approach. So let's get in the right place. We'll add a security context. We'll ensure this is running not as root, and and it's running with a read-only file system. So improve. We'll just commit direct flow master for this. So with that, we'd see GitHub send a webhook to Snyk, and we'll automatically retest that project behind the scenes. In my case, I'm actually also generating the resulting Kubernetes configuration file, and that will also then trigger a rebuild. But we'll force a refresh there. And that's the generated one. Oh, I think that's just rebuilding it. Okay, yep. And there you can see that we've changed the original file, and we've got fewer vulnerabilities showing up. And as the basically, I've got a GitHub action that's going to generate my actual final file, that will also trigger a retest and an update of the UI. Another thing I'll show here as well is that we're conscious that to start with, we've got a fixed set of issues we're picking up on, but you might not quite agree with our opinions there. So we make it really easy for you to override those. So maybe it's that you want to globally ignore the fact that some of these are actually not things you care about, or that you disagree with the priorities. So here you can, here I'd actually already changed the priority of whether the container is running as root to make sure that flags up a bit more prominently. We're currently working on adding a lot more policies, and they'll have the same ability for you to sort of reconfigure as well. So jumping back to the slides, like what we saw there was really just starting with the source you already have, starting with where you're editing it in your source control system, and whether that's GitHub or GitLab or Azure Pipelines or Bitbucket, wherever that you're storing your source code, Snyk can connect to that and then surface the issues. We make it really easy for you to import those repositories into Snyk in exactly the same way as existing Snyk users are doing with their application projects or their container projects. We then detect not just the application vulnerabilities, so whether that was, in my example, a Ruby application, in the example shown here, a Node.js application, but we're picking up on the configuration files alongside them. And this might be the case that you have microservices with local configuration. You might also have a quite common pattern of having a central repository where you have all of your Kubernetes configuration files. Both of those use cases will work with this tool. You just point them at the repository and we'll pick up on the issues. And we put those issues in context, as you saw. It's not just saying, well, you have these problems, work things out. We want to make this as actionable as possible. We're saying this line in your configuration file is introducing this specific problem. As I said, we'll go further than this soon by making that even basically more automated to help you fix it. But we're not quite there yet, but we're getting there. And we're already starting to put it in context. And last but not least, we're also conscious that, as I said, people are using lots of different tools around the Kubernetes configuration space. Some of them will work perfectly well with this approach. So customized configuration files and YTT templates, as I was just showing, work great because they're fundamentally just going to be providing the YAML configuration. However, something like Helm takes a slightly different approach. Here, they're providing actually templates that will generate it. So you don't necessarily have a valid YAML document, you have that interspersed with the Go templating syntax. We now are just rolling out the feature to basically work with this as well. So we'll automatically build each of the templates and present those all together. So we can scan a whole chart in one go and give you configuration and security information about that too. And I mentioned as well the ability for you to customize or ignore specific rules, really to bring your own sort of opinions here. In the future, we'd really like to basically allow you to bring your own rules as well. But so let us know if that might be of interest in the future. So rounding up on the sort of topic, and if all you take away from this really is that, like, I guess configuration is now part of your application. Increasingly, it's the developers who are building the applications who are having to configure it. And there are definitely pros and cons there, but it needn't be that those developers have to become the sort of expert in all of the arcana. We want to basically use Snyk to surface that information to those people. Because ultimately, you can help secure your Kubernetes applications by writing more secure configuration. Getting this right really sort of raises the barrier to entry for an attacker. A well-secured application, running on a well-secured cluster, running in the context of the application itself, the deployments and the services being well-secured, really poses a higher barrier to entry. And that can only be a good thing. And finally, and last but not least, certainly, Snyk now finds those types of security issues in your Kubernetes configuration files, as well as finding issues in your open source libraries and container images. We really want to provide you one developer-focused tool to find security problems in whatever code you're writing. And with that, thank you for listening. If you're interested in trying this out, and do sign up at Snyk and you'll get access straight away to this functionality. If you're an existing Snyk user, we're just rolling this out now. You might already have it in the settings. If you don't, it'll be available for you over the next week. With that, over to any questions we might have. And thank you very much for listening.
Yeah, thanks everybody. Just a reminder, if you do have any more questions, there is the Q&A panel. Feel free to add your questions in there and I'll bring them up. I do have one or two here. They're fairly easy, but we'll bring them up because I think they're good general questions. The first one is, does this work with any Kubernetes environment, or are there specific distributions?
Oh, yeah, good question. So this is very much generic to any Kubernetes distribution or platform that you're using. The reason being that we're integrated at the source code level. We're integrating at the configuration before you deploy it to the cluster. So whether you're using EKS or AKS, or you're using OpenShift, or you're hand rolling your own Kubernetes from the upstream, ultimately you're still writing the configuration files against the APIs, and it's that we're targeting. That means this is general, irrespective of which Kubernetes distribution you use today or tomorrow.
Great, thanks. Yeah, another one that I think is fairly simple. I think you did talk about this, but just to make sure, does this work with anything other than Kubernetes YAML? I know you mentioned Helm on there as well.
Yep. Yeah. So today it will, supports like natively just Kubernetes configurations written in YAML. We also support JSON variants. So if you're using JSON instead, that will work as well. Less common, at least in the examples, but I know a lot of users use JSON when they're generating files rather than generating YAML. Helm, obviously, we mentioned Helm charts support will be available very soon. If someone's very keen, do get in touch and we can enable that a bit earlier for some early feedback. This does work quite well with a number of other tools as well, without like sort of, I guess, native support. I showed the examples there, not really on purpose, but I was using YTT from the K14S tool set. It works perfectly with that. Anything that's providing basically a sort of basically an actual valid YAML file, this should work pretty well with. In other cases, what I've been doing is rendering those files out to the repository using a GitHub action or similar built-in tools or Circle CI or whatever it might be, and then we'll automatically pick up those generated files and scan those. So a number of different approaches, irrespective of which Kubernetes development tools you're using.
Great. Yeah, and then the last one that I have here, unless any others come in, and I think it's kind of called out on this last slide, but just to make sure it's clear, do you have to have a paid Snyk plan to use the feature?
Nope. Yeah, nicely called out here. This is available for all Snyk users, completely free. So I guess like stepping back there, Snyk across the board provides free tooling for application vulnerabilities, for container vulnerabilities, and now configuration. We provide basically a limited usage on those, but certainly for individuals, for standard usage, those limits are suitably high that you probably don't need to worry too much. So yeah, this is available free of charge at the moment.
Fantastic. Well, that's all the questions I had. Again, I want to thank everybody who joined us today. We appreciate it. Feel free to go sign up, start using the feature, and we are eager to hear what you think and what you want to see us do next. Appreciate it. Thanks, Gareth. Thanks, everybody. Talk to you soon.
Thank you, everyone.